Encoding categorical variables in Pandas. In this lesson, we will learn how to work with categorical data in Pandas and transform text labels into numerical codes using practical, real-world datasets. By the end, you will be able to choose the right method for encoding, know when to use each, and avoid common pitfalls. Running the cell now. Get ready to unlock more of Pandas' power with categories. To make our notebooks tidier, we are telling Pandas not to show warning messages. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This initial code sets up a clean environment by suppressing warnings and fixing the random seed for reproducibility. While there's no visible output, this step ensures that the results of encoding categorical variables are consistent and free from distracting warnings, which is crucial for clear, reliable analysis throughout the lesson. Let us jump in with a real dataset. We will be exploring the Titanic dataset, a classic for data science practice. We import Pandas for data handling. We load the Titanic data directly from a public source. Now, our data frame is ready to use. We print its shape to see how many rows and columns we have. Here is a peek at the first 3 rows to see what the data looks like. Running the cell now. This output confirms we successfully loaded the Titanic dataset with 891 rows and 12 columns, including key categorical features like sex and embarked. Noticing the data structure and sample rows helps us understand which text columns will need encoding. This sets the stage for converting those categorical labels into numerical codes for analysis. Take a look at the column names and spot any non-numeric columns. What are categorical variables? Categorical variables are columns with a limited number of values, usually text labels. For example, sex and embarked in Titanic are categorical because they use labels like male, female, S, C, or Q instead of numbers. Running the cell now. Can you think of another real-world example? Let us identify which columns contain text data, which Pandas calls object dtype. We collect the column names with that type. We print the names as a list, so we can see which columns are categorical. Running the cell now. This output lists all the columns in the Titanic dataset that contain categorical data, identified by their object data type. Notice how sex and embarked are included, matching our definition of categorical variables as columns with limited, text-based values. This step helps us focus on which features we can analyze or convert for modeling as categorical variables. Notice columns like sex, embarked, and a name. We'll focus on the clear categories. Let us find out how many unique values are in each text column. We loop through our object type columns. We print both the column name and the count of its unique values. Running the cell now. This output shows the number of unique values in each categorical column, highlighting how some variables have many distinct categories like name and ticket, while others like sex and embarked have very few. Notice that variables with fewer unique values, such as sex, 2, and embarked, 3, are more typical categorical variables that can be useful for grouping or analysis, which aligns with the lesson's focus on identifying categorical data. Columns like sex and embarked look easy to encode, but name or ticket have many unique values. Why encode categorical data? Most machine learning models require numbers, not text. Encoding categorical variables turns words into digits, letting algorithms learn from them. There are 2 main strategies, label encoding and one-hot encoding. Running the cell now. Let us see label encoding first. Label encoding means turning each category into a number, like 0 or 1. We create a new column called sex_encoded by converting sex to Pandas category type and using cat.doc codes. Let us view the first 6 rows to see how a male and female become numbers. Running the cell now. This output shows the result of label encoding the sex column, where a female is mapped to 0 and a male to 1. Notice the consistent numeric labels correspond directly to the original categories, enabling machine learning models to process this formerly text-based data. This step is crucial because many algorithms require numeric inputs rather than strings. Try predicting which value does female use, 0 or 1. Sometimes you may want to assign specific numbers to categories instead of using the default order. We build a Python dictionary that maps each port code to a number. We use map to apply this mapping to the embarked column, creating embarked_encoded. Let us view the first 6 results to check our mapping. Running the cell now. Here we see that the embarked column transformed into numerical values using a custom mapping, with S as 0, C as 1, and a Q as 2. Notice how each original category now corresponds to a unique number, enabling models that only accept numeric inputs to process this data. This step illustrates label encoding, a simple but effective way to handle categorical data for machine learning. Making a mapping dictionary gives you control over the codes. Pause and try to change one of the mappings to see the effect. One-hot encoding, when to use it. One-hot encoding creates a separate column for each category, using 1 for present and 0 for absent. It avoids implying order or priority, which is important for unordered categories. Running the cell now. Let us see how Pandas does this automatically. We use Pandas get_dummies to quickly create one-hot encoded columns for the embarked feature. The new data frame has one separate column for each port, using 1 to indicate the passenger's port. Here are the first 6 rows so you can visualize the result. Running the cell now. The output shows the one-hot encoded columns for the embarked feature, creating separate binary columns for each port, C, Q, and S. Notice that each row has exactly one true value, indicating the original category without implying any order or priority. This confirms that one-hot encoding effectively represents categorical data for models that require numerical input while preserving category neutrality. Notice only one column shows a 1 per row. This is a typical encoding for non-ordered categories. We add our new dummy columns to the original data frame, keeping all of the original information. Now our data frame includes both the encoded columns and the original columns for comparison. Let us show the first 3 rows to see the result. Running the cell now. Here, the one-hot encoded columns embarked_C, embarked_Q, and embarked_S have been joined back to the original data frame, creating separate binary flags for each port of embarkation without implying any order. Notice how each row has exactly 1 among these columns, reflecting the specific category for that passenger. This confirms the intent of one-hot encoding to represent unordered categorical data in a clear, non-hierarchical way. You can drop the original text column later if you want to save space. This comment explains that we will encode multiple categorical variables simultaneously. We list the columns we want to one-hot encode in a list called cols_to_encode. We create a new data frame df_multi by applying one-hot encoding to the specified columns. We print the first 3 rows of the new data frame to verify the encoding. Running the cell now. This output shows the result of one-hot encoding applied to the sex and the embarked columns, where each category has been split into its own binary column without implying any order. Notice new columns like the sex_female, sex_male, and the embarked_C, embarked_Q, embarked_S, each indicating presence, 1 true, or absence, 0 false, for that category. This highlights how one-hot encoding expands categorical features to prepare data for models that require numeric input while preserving the unordered nature of categories. See the pattern? New columns were created for each original category. If a categorical column has missing values, encoding can cause problems. We create a filled copy of the embarked column, replacing missing values with the word unknown. Let us check the first 8 values for any unknown or unknown. Running the cell now. This output shows how missing values in the embarked column are replaced with unknown in the new embarked_filler column, ensuring no nulls remain before one-hot encoding. Notice the shape remains unchanged, but now every entry has a valid category, which is crucial to prevent errors or misinterpretation during encoding of categorical data without implicit order. Filling missing values keeps all rows safe for machine learning. Now, if we use get_dummies on embarked_fill, we get an extra column for unknown. This extra column helps us track which values were missing. Here are the first 8 rows to visualize the full set. Running the cell now. This output shows the one-hot encoded version of the embarked_fill column, where each category, C, Q, S, unknown, becomes its own column with true/false values indicating presence. Notice how no ordinal relationship is implied. Each row has exactly one true value, preserving the original categorical information without bias. This confirms the intent of one-hot encoding to represent unordered categories distinctly for modeling. It makes sure every row gets encoded, even if the original value was missing. Categorical data type for efficiency. Pandas offers a special category dtype which saves space and speeds up some operations. It is very useful for columns with a handful of distinct values. Running the cell now. Let us change the column type to see the difference. We convert the embarked column to Pandas category type, which helps with memory and processing. This column now knows about its categories as a data type. We print the new type, which confirms it is now a category. Then we show memory usage to illustrate how much space this column uses in memory. Running the cell now. This output shows that the embarked column has been successfully converted to a categorical data type, as indicated by the category dtype. Notice the memory usage of 1281 bytes, which is typically much smaller compared to storing the same data as strings. This demonstrates the efficiency benefit of using categorical types for columns with a limited number of unique values. Category types are great when you have thousands of rows but only a few unique values. Some categories have a natural order, like decks on a ship. We make a dictionary where each letter deck is mapped to a number, and unknown gets 0. We pull the first letter from each cabin to find the deck, filling missing values with unknown. We encode this deck column using our mapping. Here is a sorted list of encoded decks and their values to see the order clearly. Running the cell now. This output shows how the deck categories from the cabin column are mapped to ordinal integers using a predefined deck_map. Notice that recognized decks A to G and unknown have numeric codes, improving efficiency for analysis, while the unexpected deck T is not in the map, resulting in NaN. This highlights the importance of defining and encoding categorical levels explicitly to leverage Pandas category dtype benefits. Use ordinal encoding when the order of categories is meaningful. Let us try turning the passenger class column, P-class, into a category type. The P-class_cat column now holds category values instead of integers. We peek at 6 rows to check our work. Running the cell now. Here, the P-class column is converted to a categorical dtype, which you can see matches the original values but is now stored more efficiently. This transformation is key for optimizing memory usage and speeding up operations on columns with a limited set of unique values, like passenger classes in this Titanic dataset. Notice how the values remain the same, confirming that the type change preserves the data while improving performance. Give it a try. What other columns could use category types? If you are following along on YouTube, hit pause and experiment. Troubleshooting encoding problems. Nulls or spelling issues can break encoding. High-cardinality columns like name are not good for one-hot encoding. Recheck for unexpected new categories before predicting. Running the cell now. Let us wrap up with key learnings and a call to action. Recap. Label encoding is best for clear, ordered categories. One-hot encoding is right for unordered choices. Always handle missing data before encoding. The category dtype economizes memory. Ready for a real challenge? Try encoding ticket using frequency or target-based methods. Running the cell now. Let us keep building skills and sharing what we learn. Keep learning and connect. If this helped you out, remember to like and subscribe for more practical Pandas walkthroughs. Leave a comment sharing how you use encoding in your own projects. Running the cell now. Thanks for learning with us. See you in the next lesson.